Docker containers are one of the technologies I love using so much because I can really just deploy any kind of software using it. Now, of course, there's caveats to this, but I can't think of very many. The idea, though, is as soon as you create a container, how do you deploy it? There's many different options. There's complicated options like Kubernetes, but then there's also simple options like what we're going to do with HashiCorp's Nomad. Nomad is a container orchestration tool that really just makes it a lot easier to deploy your containers into production. But of course, just using Nomad by itself isn't enough. We actually want to go beyond just one instance of Nomad. We want to build a highly available cluster. That is, if one of the instances goes down, your Nomad system, your entire system, both the servers and all of the containers that are running, don't necessarily go down, or at least they don't go down for very long and they come back up as soon as possible. Nomad is designed to do this, and it does it in a very, very effective way with very low stakes. Now, the way we actually get this going is by using Terraform to turn on all of the infrastructure, all of the virtual machines we want to run, and then we use Ansible to configure all of them to make sure that Nomad is running. Now, Nomad itself is not that complicated to configure, but there are dependencies that Nomad needs in order for it to run and run containers correctly, which is why we actually use Ansible. Ansible will do all of that configuration for us. And even if you don't know Ansible, I'm going to give you a really quick rundown of how you can go about using it. Terraform will actually explain in a lot more detail because it has more implications on the cluster itself. As in, you can provision something way too big or way too small using Terraform and doing the wrong configuration, where Ansible doesn't really have those kinds of implications. Now, the other thing that we actually implement is something called HashiCorp Console. Console will give us the networking so that all of the things we deploy inside of Nomad can actually communicate with each other, so we can actually deploy a load balanced service, which is what we wrap up with. So let's go ahead and take a look at the requirements you'll need to do well in this one. Now, first and foremost, you're going to need an Akamai Connected Cloud account. This is formerly Linode.com. The reason we need this is to have virtual machines. All of the virtual machines that we want to run our containers on, and Nomad we're going to be using on Akamai Connected Cloud. So go ahead and sign up at linode.com/Justin right now for that. If you go to that link, you will end up getting a credit for your account that you'll be able to use to pay for everything in this series. And of course, if you already have an account, feel free to use that one as well. Now, the other idea here is we are going to be deploying Docker containers. While it would be pretty useful to know containers already, I'm going to show you a bunch of examples of what you could use just to deploy a container right now. This hopefully will spark some interest to learn more about containers, because to me, it's a fundamental technology that so many more people should know how to use, because what it does is it allows your application to run anywhere. So the idea here is if you were to deploy something, let's say for instance, a Django Python web application, you want to deploy it to virtual machines. You're going to need to make sure that those virtual machines have Python installed and all of the other dependencies that might come in with Django. But if you decide that you want to actually start running a Node.js application, which of course is a JavaScript runtime, your virtual machine is no longer configured to run Django. So what you do then is you put both of them into Docker containers so that your virtual machines are already provisioned and ready to start running those containers. This of course presents a whole new problem, is how do we reliably deploy those containers in production over and over and over again without or as minimal of downtime as possible. That's where Nomad comes in, and that's why we're going to be using Nomad. It helps us orchestrate this process from taking a container and putting it in so that it runs, and it runs in a very reliable way. Nomad is a great way for this. This is also a very low stakes way to do it versus something like Kubernetes, which is definitely more full-featured, but it's quite a bit of a learning curve in comparison to Nomad. Nomad is, well, just some basic configuration overall that has a lot of built-in features that make it really straightforward to get this going. Now, you can use Nomad and Kubernetes in tandem with each other with the same containers, because that's how containers work. Once you have a containerized app or database or something like that, you can deploy it in many different places. Nomad's just one of those options, which I think is a really worthy project to look at and learn about. So how do we actually get all of this working? We will be using Terraform to turn on all of our infrastructure. Terraform will basically log into your Linode account for you. It's not going to log in, it's going to use the API, but it's going to go ahead and turn all of the virtual machines you might need. Now, the big reason for this is so you can track these changes over time. This is good for going back in time and going, hey, what did I actually turn on for this project? It's also really good for scaling things up. So as soon as you need a more robust cluster, Terraform is going to make that a lot easier to do, as well as if you need to roll things back. Then clicking through and doing ClickOps, trying to actually go into the console and do everything manually. That is definitely something you could do, and it's actually not that hard to do. But the idea is we want to keep these things tracked, so we use Terraform for this. I'm going to show you exactly how to set all of this up. Next, we're going to be using Ansible. Ansible is a Python tool that allows you to configure what's going on inside of the virtual machines. Terraform turns everything on. Ansible configures and makes sure that they're all working and running correctly. So that means we're going to install Nomad using Ansible. It's a very automated way to make all of that happen. You can do it manually, but we want automation as much as possible, especially when we want high availability, when we want to create a cluster that makes sure that all of this is working. So that's a key part of all of this as well. Now, it's important to know that the Terraform docs are going to be where we start. These docs are going to help us turn everything on, and I reference this all of the time. I rarely ever try to remember everything in terms of what we're doing here. Another reason to have everything in documents. Another reason to use Terraform, Nomad, Ansible, all of that stuff. So that being said, there is a GitHub repo that we have for this entire series. That was also a webinar, a live webinar. But the idea is if you go to this link right here or scan that QR code, you're going to see most, if not all, of the code that we're doing in this series there, so you can actually repeat everything we're about to do. So of course, if all of this seems like something, yeah, you could do this or it feels reasonable to be able to do, let's jump in. If it doesn't feel reasonable to do, but you still want to do it, let's jump in. And if it feels incredibly uncomfortable and you still want to do it, let's jump in. So let's go ahead and take a look at how to terraform a Linode virtual private cloud right now. I'm going to be using Visual Studio Code as my text editor for this one. Feel free to use any of them. I really like using Visual Studio Code, which is why we're going to do it this way. So once I open up Visual Studio Code, I'll open up this Explorer here, and I want to designate a new folder for this project. This folder, I'm just going to go ahead and call it Nomad Cluster, and we'll go ahead and open this up, and I'll go ahead and save this workspace as a simple Nomad Cluster. Then I'll go ahead and actually create a new folder called Infra, which is where we're going to put all of our Terraform modules in there. And I'll also go ahead and initialize Git. So if you actually go into the source control tab here and initialize this repository, I'll go ahead and do that. Now the reason I'm mentioning this is because I do this on every series myself, even though you don't necessarily see it. So what we want is we want to bring in our Terraform git ignore right away. I want to just make sure that I have this one. I'll go ahead and do raw, and I'll copy this whole thing and bring it in to my project here as .git ignore, and we'll paste this in. There's credentials that we will be storing with Terraform in just a moment that we definitely do not want to expose to the outside world, which is why we want to put git ignore in right away. And of course, you can go ahead and do something like initial commit here and just make sure that it is in your project already. Great. So the nice thing about VS Code is we can see stuff like if I do terraform.tf vars, what I see is it should be grayed out. Whereas something like main.tf, both things we will configure in just a moment, you can see that it is green. That's the key here, because what we want to do now is we want to get our Linode API token. Now, this API token is how Terraform can communicate with the Akamai Connected Cloud API or the Linode API. The way we're going to do that, of course, is by jumping in to our actual console here. So in the Linode console, you're going to go ahead and click on your username here, go to API tokens. We're going to go ahead and create a personal access token. Now, I do recommend limiting access as much as possible. In our case, I'm going to just go ahead and have my Nomad cluster in here, have all read and write, do go through what you need and what you don't need. Some of these things you might not need, like stack scripts or account access, but do keep in mind that the errors will show up if you do not have permission when you try to do it on your Terraform account. So what you see right here is my personal access token. I'm going to go ahead and copy it and paste it into my terraform.tf vars. This will be the last time you see this token. I shouldn't share it at all, but the idea is, of course, at any time, if you need to revoke a token, like I've got this webinar one in here, I'll go ahead and revoke that, right? I've got the sample one in here. I'm going to go ahead and revoke that as well. Sample one, boom. Okay, really simple. It's not hard to make new tokens, as we just saw. So what we need to do, of course, is create our virtual private cloud, our VPC. Now, yes, we of course have the option to go into the console, click on VPC, and just create one. That is totally fine if you want to go this route. But the thing is, bringing things down and tracking our changes is exactly why we want Terraform there. Bring them down, bring them up, do all the testing we want. Terraform is going to be how we do that. So in order for us to get this started, the first module I'm going to create in Terraform is main.tf. I want you to keep in mind that any .tf gets treated as one big file. So oftentimes you'll see Terraform as one big file. Sometimes you'll see it as small, broken up files. I like having them small and broken up so I can actually track all of those little changes as individual modules, as we'll see in just a moment. So one of the things I definitely don't do is try to remember all of these different configurations. I tend to use them a lot, so of course I think things I do actually remember, but if you go to registry.terraform.io into providers and just search for Linode, you will find the Linode provider and the example usage. So we've got these things right here. The first lines are what we're going to bring into main.tf. So what we've got is, we've got the required providers. This is necessary to download all of the configuration to connect to the Linode. And then this provider is how we configure this provider. But we see that there's this token here. Now, one of the things you definitely don't want to do is copy this API token and put it directly into your Terraform provider. That is a big no-no. That's because this is going to be tracked by Git. So we definitely don't want to expose these tokens unnecessarily. Now, of course, you could always remove the token after you expose it, but the point is we don't want to expose it in the first place. So what we're going to do then instead is we're going to create something called variables.tf. Now, the reason we put variables in here is so that we can create the variable that I actually have in terraform.tf vars. In other words, this Linode API token here, I can now put it in to this variables. This will allow me to use it anywhere in my Terraform modules as long as it's defined. And the nice thing about VS Code is it will start to show you these things, as in var.linode API token, which is fantastic. And of course, if you're using other things in terms of your, like, if you have like GitHub's Copilot installed, this makes it even easier to do all of those things. But the idea of this is just to make sure that our tokens are outside the scope of the actual modules themselves, outside the content itself. So the type here is going to be a string. You don't necessarily have to declare this. This is going to be the default. But what we want to declare is the sensitive value. This is a sensitive value, so we're going to go ahead and say true. So you could also put in a description if you want. Sensitive is the key one. The reason being is we don't actually want this to be exposed ever. We don't want even in the console to show this sensitive token itself. So that's it. This is all we need to really conditionally render out our Terraform installation process. So in order for this to work though, you're going to need to make sure that you have Terraform installed. So if you go into HashiCorp or terraform.io and click on download, this will allow you to have Terraform work. Now in my case, what I did was brew install Terraform because I'm on a Mac. That's not going to work if you're on a Windows. But once you have Terraform installed, you will be able to do Terraform -- version, and you'll see which version you have. My version is a little bit older, but I think it should work just fine. So I should probably update it, and feel free to do so. But the idea here is now that I've got this, I'm going to go ahead and navigate into my infra, and we'll go ahead and do Terraform init. So the Terraform init is only going to need to be run pretty much one time. If you make changes to these required providers, you might have to run it again. But the idea is this is going to initialize that Terraform project. And the reason I'm in the root of that project is to make sure it happens right next to where all of my modules are. Now, there's another way to do this, which is using chdir, and then you could do something like this, where it's /infra. That is another way to do it, of course, but I'm just going to go stick with Terraform init, and this is going to initialize my project here. So what it's going to get for me is a version of the Linode provider. So one of the other things that is definitely something you should consider is going back into the registry and grabbing whatever version's available right there. right? So that version is also going to be most likely in the docs itself. So you can always grab what that version is somewhere in here. But basically 2.23, so we'll go ahead and do 2.23.1. That is the one you would probably want to pin to your code itself. Going back into the Terraform registry for the Linode provider, we're going to do a quick search for VPC, and we're going to grab the resource of Linode VPC. Now, virtual private cloud helps us isolate our resources from other resources in the cloud environment, whether it's our resources or somebody else's. But the idea is once they're all connected, we can also define our own IP addresses for each individual instance, these private IP addresses and how they connect, which makes configuring what we're about to do really straightforward. We can both have the exact same private IP addresses because of these virtual private clouds, because there's no overlap whatsoever, because our VPCs are going to be isolated from one another. So let's go ahead and create our very first VPC by just using the docs here. I'm going to go ahead and copy this one, and I'm going to jump into my Nomad infrastructure here, and I'm going to call this my cluster_vpc.tf, and I'm going to go ahead and paste this in. Now, keep in mind, Linode, the actual provider, is already configured so that I can just start using these different resources in here. Now, this resource is probably fine. I could probably go off of this one. But the idea here is the region that I might want to use. So Linode has a bunch of different regions that are available here. So if I did the Linode API region list or something along those lines as far as the search is concerned, we should be able to look for the various regions that are available to us, right? And so if you actually take a look at the docs here, we can actually grab this regions list here, and I can open that up and then see all of the different regions that are available to us. Now, I don't know if all of the regions will necessarily support what we're about to do, so do keep that in mind. I think the vast majority of them do at this point, but the idea is the default is in Washington, D.C. So what I'm going to do is I'm going to change the default, my default, to being in Chicago. Now, as soon as I actually change a default like this, or I'm aware of defaults changing like this, I think variable. This is something that could change over time. So right off the bat, I actually grab a new variable here. And this one I'm going to go ahead and call my Linode region. And this is no longer sensitive, so I can get rid of this. And we'll go ahead and say our Linode region. So when it comes to the VPC and all of the instances in it, we want to make sure that they're all in the same exact region. This time I'm going to go ahead and set a default value in here. This one is going to be my US ORD, which of course is just simply Chicago. And you can see that inside of the docs there, which I will also put in to the code right here, just to remember exactly where those regions are. As soon as I do that, I go back into my cluster VPC here, and I change the region from just region to being var dot, and then the Linode region. Simple. I will reuse this quite a bit throughout. So let's go ahead and make sure that everything is saved. Not quite sure why this is giving me this error right now. Maybe it hasn't updated. There it goes. The label itself, I'm going to go ahead and change this label here, and I'm going to call this my HA, my high availability Nomad VPC, and then I'll go ahead and give that same label in here. This label is what goes into Linode. This one right here is for Terraform. So they are definitely different. I don't necessarily need a description, but I'll go ahead and say my Nomad VPC. Great. So once we actually have a VPC, then we can actually define our subnet. So if we go back into the docs once again, we can see there's a VPC subnet. This we could use all of the default values for as well. Definitely take a look at how IP address works for your use case. If you need more IP address numbers in your case, you can definitely take a look at how that's done. I think cider.xyz is a really good one. So cider.xyz. You can actually see the various IP addresses that you might want to use. So in the default that we've got on Terraform is 000 and then /24. We see there's quite a few IP addresses we can use with this VPC, but you can always change it as well. If you go up in numbers, you get less. If you go down in numbers, you get more. Now, not all of these are necessarily going to work, so definitely check them, try them out, do all that. Next up, let's go ahead and grab our VPC here, and I'm going to bring it right underneath my resource for
the actual virtual private cloud. So I'm going to go ahead and rename it. So we've got our name here of HPC or VPC. This one I'm now going to go ahead and just go and do -subnet. That's it. Okay. The VPC ID is going to come from this resource up here. Now, if you've never used Terraform before, this is going to be kind of weird. But the idea is we grab the resource name, then we do a dot. We use dot notation here. Then we grab the resource label that we gave it, again, for Terraform. This label doesn't matter at this point. Then we're going to go ahead and grab the .id here. I'm going to show you exactly where we can see this if you were to do these in different steps. We're doing it all in one step, but if you wanted to see in different steps, let's go ahead and take a look at that in just a moment. Next up, we're going to go ahead and grab in our Nomad VPC. This label is now going to just be simply subnet. We're going to go ahead and save it. Now we're going to go ahead and do all of our Terraform stuff. I am still in the root of the infra directory. So what I'll do first is Terraform plan, hit enter. What this will show me is all of the changes that will be made to my infrastructure. You can save this plan and then you can apply this plan later. So if you needed to save this plan and then have somebody review it, you totally could. In our case, we are not going to have anyone review it. We're just going to go ahead and apply this plan with Terraform apply, hit enter. This is going to ask you again if you want to actually do these actions for this plan. In my case, I'm going to go ahead and say yes. So what we can do is we can verify this inside of our console. So if you jump into your Linode console itself, in my case, here it is. I'm going to go ahead and bring this one up a little bit, and I'll close out some other tabs that we don't need anymore. There is my HashiCorp high availability Nomad VPC with my subnet. Now, I do recommend for this series following along with the exact same subnet, but if you wanted to change it, this is where you could change it. So let's say, for instance, you wanted to change it to /20. Once again, you could plan things out. It's going to show you this. It's going to replace this VPC, or at least the subnet of this VPC, and then you can go ahead and apply it. And those changes will then, in theory, go through. And so if we refresh on this VPC, then we can see that subnet range has changed. Once again, I'm going to stick with exactly the same thing that we're all doing, but this is why we actually have those Terraform files, these Terraform modules. It allows me to make changes really, really quickly. The other thing is, like the region, for example, the region, you could change it right now, and it will actually change the region that it's going to end up working in, while the subnet ends up staying the same. Also very, very nice. Great. So with this in mind, we now want to actually see how do we actually pull this out. I'm going to show you the console inside of Terraform because it's actually very, very straightforward, and it's a way that you can test things out and really just learn that much more about Terraform. Terraform is a declarative technology. All this means is we actually declare what we want to have happen. We write what we want to have happen, and then we tell Terraform, hey, go do this. It does it behind the scenes without us really intervening whatsoever. So actually learning how to use the console can help a lot with this declarative nature. So, for example, this actual VPC ID here, the reason that works is because of what Terraform does behind the scenes. First, it understands, it sees this right here, that it's using another resource. So it understands that that other resource needs to come first, and then this resource comes second. For us, that doesn't really matter. We just know that, hey, we want to use this VPC's ID, so go ahead and make sure that that works. So we'll take a look at the console in just a moment to see that in action with the console if you ever need to understand what's happening or unpack anything that's happening on any resource. We'll come back to that console again in the future. But the other thing about using Terraform is terraform.tf state. This state right here is an actual file that has a lot of sensitive information into it that actually shows us exactly what's going on with our state. There's a way to set this up in the cloud and specifically on Linode Object Storage, but the idea is we aren't going to touch that right now, but it does and is a very important file itself. Now, the reason it's grayed out, of course, is from git ignore, and off the video, I've been tracking all of the code with Git, but the idea now is I want to show you exactly how this declarative nature really helps us out. So inside of my terminal here, still inside of the Terraform folder, I'm going to go ahead and run Terraform and console, hit enter. To exit it, you just type exit, and you can re-enter just like that. And so what we've got here is I'm now able to see different resources that are happening in Terraform. So for example, my variables here, I've got a few different variables. I can do var dot and then whatever variable name, in this case Linode region, it'll actually show me which region I'm currently using. It will also take into account the TF-vars. So if you did change them in the TF-vars, it will show that right here. Now another thing that we can do is we can see the VPC itself. So again, grabbing that resource, dot, and then the actual label we gave it in Terraform, dot, and hit enter, we can see all of the things about this. These are all available for us to use. This is a dictionary or an object in other languages, but the idea is we can use it in dot notation, so I can do dot created, and I can see exactly when it was created. So this might be really useful for our logs. We can also see when it was updated, which might be a little bit different. Overall, it's the same in this case, but the VPC didn't change at all. We didn't change it. We didn't touch it. What we changed was the subnet itself. So then, looking into our subnet, we can see exactly that subnet data. And we can see all of the outsourced the resources that are available in here. And there we go. We see when it was created and then when it was updated. So the problem, or the thing that's important to note here, is this VPC is a different one than the first one we started with. We actually destroyed it when we changed it to 0. It deleted it and then brought a new one into the mix. So that's something else that's kind of interesting to know about how Terraform ends up working. It might delete resources that you aren't aware of it deleting, and it also might not delete resources. It might just change them or modify them. So seeing the created or updated part will help indicate that to us. And so the reason we were able to use this ID here is because, well, number one, we definitely needed to correlate this subnet to our VPC. That's a requirement. But also, we need to make sure that it was this one in particular, because you can have other subnets for that one. So you can basically reuse this over again with a different IP address or a different range, a CIDR block range than what we've got here. But that's the key. We've got a bunch of different things that we can use in Terraform itself, and then the console makes it easier to unpack these things. But the thing is, as soon as we start using the console, do keep in mind that some of the resources might need to be provisioned already. So for example, if I go back into the registry here, let's jump into the registry, and I'm going to go ahead and type in instance, and I'm going to grab an instance, and I'm just going to copy and paste this one right here, even though it's not a great instance. I just want to show you an example of what I mean. So if I were to paste this instance in here and then run into the console and try to do the instance.web and hit enter, it gives me this known after apply. In other words, Terraform is not aware of what's going on with this just yet. So if you needed additional data or information about what will happen with this particular resource, that is where the documentation comes in a big way. So we see this resource instance here, and we also see data sources. If I go down to Linode instances, we've got data sources. This doesn't exactly show me exactly what I want to know. So let's go back into resources, and we can see that there are attributes in here that you can take a look at then, right? And so status, that's another one. That would be the instance itself, .status. So it'd be something like this, .status, and that would actually show you what that status is. If I use some gibberish here, it gives me unsupported attribute because, well, it doesn't actually have one. And so you can see all of the different attributes that are available as well, because there's a lot of them. Now, I don't think you should get bogged down into too much of these details. What you should really be doing is starting to use it in a practical manner, which of course is what we want to do now. We actually want to use this VPC to create our instances. So the idea here, of course, is to jump into the Terraform registry, look for the Linode provider and the Linode instance. We're going to go ahead and use this simple Linode instance right here. Go ahead and copy that, and we'll go ahead and bring it into infra, and then our cluster underscore instance.tf. We'll paste this in. There we go. So this, of course, is the resource itself, which does need some configuration. We can't just use this out of the gates. The very first one is fairly easy, and that's the region itself. We need to make sure this region and the VPC region are the same. So luckily for us, we have a variable that we can easily reuse and just paste it in like that. The label itself, well, we could use this label, but I'm going to go ahead and auto create one within the Linode API, which means that I just comment out the current label that it is. Next up, what we want to do is our authorized keys or our root password. So as it stands right now, this password is not a safe one, so I'm going to go ahead and get rid of it. Next up is going to be our authorized keys, otherwise known as our SSH keys. So you could hard code your SSH keys in here. You could also use it as a variable. We'll see a little bit more of an advanced usage of that in the next part. So you could always do that, or you could use something called authorized users. And here we could actually put in a list or an array of different usernames we want to have. So in my case, my username is Justin Mitchell, so I could hard code this in here as well. Or I could use another part of the Linode provider. This is a data resource, basically. So if we come in here, we've got data sources. If you actually look for the Linode profile, you will see that it is a data source, and you can just reference it just like that. And so we're going to go ahead and do that. This one I just did profile. I'm going to actually call it me, just so I know that it is my profile. And I can come down in here and do data.linodeprofile.me, then .username. It's that simple. Of course, that maps then to my Linode account, this username right here, which also has some SSH keys installed. So if you don't already have an SSH key or you don't know how to do it, that's not what this video is all about. It's really easy to do. You can actually even see it, SSH RSA. There's a lot of different ways on how you can create an SSH key that you can then put into your account. This definition right here will use that account SSH key. This one right here will use one that you specify. Specifying your own SSH key or a public key specifically, not the private key, but specifying your own public key can be really useful if you plan on pushing this to the cloud as well, or having other people be in charge of doing, Terraform apply. Great. Next up, I'm going to go ahead and get rid of all of these definitions here because we want to actually keep this as simple as possible and now attach this instance to our VPC. So the way we do that, again, we can go back into the Terraform provider information about this, so Linode instance, and then scroll on down past the simple one, and then do Linode instance with explicit networking interfaces. So what we see here is two of them. So I'm going to go ahead and bring them in, and we'll paste this in here. So naturally, this one is going to be for our public IP address. This one is for our VPC-based private IP address, which of course means that we need to reference the correct subnet. Now, there's a lot of different ways on how you might want to do this. Well, probably two of them. One of them is just to get the actual ID itself. The other one is to go in and use Terraform for what Terraform does well, which is that dot notation stuff that we've seen, and just make sure that you do .id. Once again, if you're confused about what that might do or what it looks like, you just come into the Terraform Console, and then you paste in the resource you're looking at, and then you look for the thing that you need. In our case, the subnet ID is going to be this value here. Using dot notation, that will be filled out. Now, the next thing that's important is the actual private IP address. We get to define this for our own subnet. So we get to tell the Linode system that, hey, we want this to be at a specific IP address. But of course, this actual IP address needs to fall inside of the CIDR block range for the subnet. Remember back to CIDR and .xyz. This is where we're talking about this here. So if I change this to zeros with 24, here is the range of IPs. And so we've got our first usable one and our last usable one. In other words, what we define here needs to fit in this range. And notice only the last number is changing. That's what you need to change. So we change this one to 0. This is now in the right subnet. And then this last part needs to be 1 or greater, basically. I actually like starting at 5. I like just saying, hey, those first few, I'm going to ignore altogether. So we'll just leave it in at 5. And now this actual instance should fit inside of that VPC. So all there is left to do is really to just apply these changes. So let's go ahead and exit out of the console. And there we go. And then I'm going to go ahead and do Terraform apply. And we'll go ahead and say yes. Notice that the VPC is in there. Say yes. Now, what's going to happen here is Terraform is going to communicate through the Linode API. The Linode API will tell you, hey, you made a mistake if you did something wrong with your VPC, or at least it should. So it'll tell you, hey, you have the wrong IP address for this subnet or something along those lines in terms of an error. What it might not tell you, probably won't tell you, is whether or not your SSH keys are correct. It's not going to verify that. At least I don't think so. Maybe at some point it might. But all of these other configurations, these are well documented on the actual Terraform modules in here. And then, of course, if you do a quick search on Google for the Linode API, this is a lot of documentation in here as well. We'll revisit this in a little bit. But for now, I just want to verify that this instance is being created in my account. So going into Linodes here, I see that it's booting. Notice that the label is just some arbitrary number. Yours is likely going to be different. The public IP address in here, there it is. It's actually available. It's showing us that. And I can copy it. I can SSH in, which I will do in just a moment. But I can also see that there is the subnet available here, as well as the VPC and the IP address that's in there as well, which you could also verify by going into the network in here also, which is great. So that means then I can actually try to SSH in here, assuming that it's all booted and running. Looks like it is. I'll go ahead and copy this. And assuming that my local SSH keys are tied to my Linode account, which in my case they are, as in my local, if I did ls$.ssh, hit enter, this ID rsa.pub is in my Linode account. So what I can do then now is try to SSH into this virtual machine, which of course, seeing something like this is a good sign. It's showing me that more than likely I'll be able to actually log in. And there we go. I'm now logged in to that instance that I can then go ahead and use. Now, this is only to show you how to do this configuration. Now I want to modify it so it actually works with Nomad, and then you can see all of the modifications and what they might end up needing to do. What's important about Nomad is there's servers and then there are clients. So what we want to do here is we want to declare both of those things. First off, the Nomad servers are what tell the clients what containers to run. Okay? And then below that, the Nomad clients, if available, will run containers, also called jobs. That's what they'll actually be called inside of Nomad. So the servers are important to keep up. This is where that high availability is extra important than the clients themselves. So what that means is, in order to have high availability, we need to have a certain number of actual servers that are running. So I'm going to go ahead and change this resource name to be simply Nomad servers. And then I'm going to go ahead and give a count, and we'll go ahead and do 3. Now, before I go any further here, I want to go ahead and just make sure that this is possible. So I'll go ahead and do Terraform plan. And I don't want to see errors here. What I do want to see is a bunch of minuses. The reason being is the old one, the web, that web instance should go away. And sure enough, that's what's happening because it's not in the configuration anymore. This is something that's really nice about using Terraform itself. I'm going to go ahead and tab a bunch of this stuff backwards and then tab it forward again so they're all kind of aligned a little bit better. But the idea is we have some certain number of count in here that we can use. Now I'm actually going to go ahead and set a label. The important part in terms of the Linode instances is the label itself needs to be unique on your account. So we're going to go ahead and change this from simple instance to being nomad-server. And to make it unique, we're going to use count.index. So this is going to be something like, we'll say nomad server -0, then -1, and then -2. In other words, the index value in there, of course, index value starting at 0. If you wanted it to start at 1, you could just do +1, and then that would actually start at 1, which is pretty cool. But we're going to leave it at 0 so we can just see what that looks like. Okay, the next thing is the actual image. So I'm going to stick with Ubuntu, but what I really want to be able to do is change it at any time or allow you to change it at any time. So instead of my variables here, I'm going to go ahead and grab the region, paste this over, and we'll go ahead and call this our Linode instance image. And we're going to go ahead and give this the Ubuntu one. So I'll go ahead and copy this right here. And we'll go ahead and paste this in and our Linode image. Great. So now with that, we'll come back into our Nomad servers declaration here and do var dot that instance image. Next is going to be the actual type, the server type. So when it comes to Nomad, in the long run, you would probably have a different server type for your client than for your servers, we're going to use the same ones all across the board. So I'll just go ahead and say type here. And once again, it's going to be maybe G6 standard 1. In fact, I actually want to boost it up a little bit by just using G6 standard 2, which is a little bit bigger. This is going to be our image type, or we'll call it our instance type. And then I'll go ahead and grab that. And once again, var.instance type. Great. So when it comes to the Nomad servers, we want it to be odd. So 1 is not highly available. 3 is. That is, 1 could go down and there'll still be 2 left. But the reason that you have them as odd is when they are all up. So when they are all up, they are going to decide what clients the containers run on. So they are going to be in a quorum, kind of have a leader that will actually vote and be the deciding factor as to the state that our clients need to be in. There will be more on that later, but for now, just keep in mind that you put them as odd numbers, 3 to 7. The clients, you can put as many clients as you like, probably starting at 3. But the idea then is we want to put that in as a variable as well. So go ahead and copy this one, and we'll call this our server count. And this one is going to be a number now. I'll go ahead and get rid of a description here. And then I'll give a default number, which in my case is going to be 3. I don't need Chicago everywhere. Okay. Server count. Back in here. Once again, var.server count. There we go. So this actually presents a new issue that comes up, and that's related to the actual VPC number. This number right here. So the way we can actually overcome this, starting at 5, we can use $count.index plus 5. Once again, if the index starts at 0, that is the same number that it was, at least the very first one. Then everyone after that will be incremented by 1. So it starts at 0, so we did 0, -1 and -2. This will be starting at, let's say, 5. We'll do 5, 6, and then 7. Something like that. Great. So those are the servers. Not a whole lot more that I need to change here. One thing I could do, though, is with my authorized keys, I could actually use my local SSH key. So typically speaking, what you could do is you could use the file function and then a path, as you see there. So this path, we can use the ~/. This gives me my root user folder .sh/id_rsa.pub. This right here is an actual value. So if I were to do cat of that, I can actually see the SSH key it's going to end up using. One of the other things about this, with Terraform especially, is we want to do the trim space here, just to make sure that we don't have multiple lines in there or anything like that. So this is really nice if you need to use a different one altogether, or really this right here, those definitions. You could then have an SSH key that's right inside of the same repo, assuming you don't actually commit it to GitHub. You can have multiple in there, which is super easy and super simple. So the actual clients themselves are going to be basically the same thing. We'll just change a few things about it. So I'll go ahead and change this to clients, or rather client. What do we call this up here? Servers. So we'll call this clients. Okay. And then we've got, instead of our server count, we'll go ahead and change this to our client count, just to make it slightly different and, well, more importantly, allow us to change it at any time. The label will be client, once again, using that same index counting mechanism. All of the image, all those variables you can change as you see fit. The final one, again, will be our IP address. This time what I'm going to do is I'm going to bring in the offset of our server count. So basically we don't want them to overlap at all. So we go ahead and bring in that offset, and then I'm also going to go ahead and increase this one by 10. This will for sure be offset from the other ones, especially when how that ends up shaking up. Now, the part about this is maybe you also want to bring in an extra count, or maybe even like 100 or something like that. There's a lot of different ones that you could end up changing with it. But realistically, your actual Nomad servers probably won't ever exceed 7. More than likely, they won't ever exceed 3. If anything, you could probably get really far with just 3 Nomad servers and maybe a robust instance type, which we have a fairly robust one, but that's outside the scope of this one. Overall, you'll probably never have to really worry too much about this VPC conflicting with the other ones, because, once again, they need to be unique in our VPC here. Now that we've got this out of the way, we're going to go ahead and do our Terraform plan. And so what we should see is everything that's going to end up happening. So that old one goes away like we tested. And I'll scroll up a bit here. Here's a new one. There's 7, there's 6, and then we should see 5, and then we've got 15, and so on. 14. All of these things are going to be now provisioned for us, which is exactly what we want. So I'll go ahead and say Terraform apply. We'll go ahead and run this. We'll approve the plan, and we'll just let it go. The next thing we really need to do with Terraform is create a local Ansible inventory file. We'll talk about that file in just a little bit. Before we get there, we need to see how to do iteration with Terraform. So our Linode instances now have multiple items in here. In other words, there's more than one. So we need to know how to iterate so we can get very specific data about those multiple items. So that's what we're going to do now. Open up the Terraform console. So we'll go ahead and do Terraform Console. And what I want to do is I want to just grab Linode instance.nomad servers and hit enter. We can see that it is a list or an array because it starts and ends with a curly bracket. But as we also see, there's just far more data in here than we actually need for any given project, or really any given output to a local file that we'll control. So we need to understand how to do iteration in this case. So the way it's done is we use our own brackets here. Then I can do a for loop, so for I in the resource we're looking at, which again was the Linode instance dot, and then Nomad servers, and bring it in here. So you define the loop first, then you define the output of the loop with a colon afterwards, and then do some brackets like this. So we're going to go ahead and create a new dictionary of items in here. What I'm going to use is I'll go ahead and say name equals to I.label, for example. And of course, we have that label right there. So all I'm trying to do is output that label inside of the console. I hit enter. There are my 3 items with that new dictionary. And so I can also do this again and do comma and do something like my IP being I.IP address. And of course, this I right here is a variable that I defined in that for loop. So a for loop, it's just going through each one. It's doing an automatic iteration of all of the available items for the Nomad server. And then we distinguish this little dictionary here. We say what key value pairs we want. Key being the name, and then value being the actual value that's inside of that current iteration. And so this gives us a lot of information, which is really nice. Now the thing that I actually want to see is I want to get the private IP address. So if we actually look at one of these items, we can just do 0 here and press enter. This gives us everything about that single one, so that index 0. If we do index 1, we will see, oops, let's go ahead and make sure it's 1 in there with those brackets. We do 2, and then we do 3. We see that it's outside that index. So the for loop that we just saw, will go through all of the available ones in there. Great. So what I want to do, though, is we want to actually take a look at one single one. It doesn't actually matter which one you look at, but we want to see one single one. And the main thing that I'm looking for is this VPC right here. I actually want to output that. I want that to be available to me on my actual, server itself. We're going to go ahead and output this somewhere. So the idea being is we use dot, and then we grab the value that it's in, which in this case, it's in the interface itself. So we do dot interface. Then we see in that interface, we've got another list here. The very first index value is the public IP address, as we see the primary purpose. The second one is going to be the VPC one, and that's the one we want to use. So we'll go ahead and do interface. This time it's going to be 1 instead of 0. We hit enter, and there is our VPC. Next up, we are going to go ahead and grab the IPv4. We do .IPv4. The reason I can know it's dot instead of a list item or a list index value is because of these curly brackets surrounding it. I hit enter. Now I see that it says to list. So once again, it's a list. There's only one item in it. So I can do 0. Now I've got a dictionary again. So I can do .vpc. And there we go. There is that private VPC. So this is going to go ahead and create the basis of what we need to do next, which I'm going to go ahead and create a new one called cluster inventory.tf, which for now, I'm just going to leave commented out. I want that VPC in there. That's going to be that first part of it. And then I'll go ahead and scroll all the way up to the iterations that I was doing. So I'll go ahead and comment that in here as well. So we're kind of close. We've got our name. We've got our IP address in here, which we might want to change to being simply public IP. And then we're going to go ahead and grab the subnet IP, which is actually equal to this value right here. And then we can grab any other data we might need for that. So now that we kind of understand how to do iteration, once again, I can just copy this now and I can go ahead and paste it in here. And there we go. So now I've got the public IP and the private IP and the name of each server itself. Once again, if we needed something like the region, so we could say region, and I believe it's just i.region. Now, the other part about how these things are defined does come back to the actual definition we gave it. So the outputs are very similar to the inputs. The interface itself is a little bit different because of how it's designed, because you can have a lot of different interface values on here. But now we've got really what we want to do the string substitution with for our eventual IP address and all of the things related to Ansible inventory files. The IP address, subnet, and all that. Terraform can also manage local files. That's what we're going to do right now, just the basics of managing a local file. Then we'll actually turn it into an Ansible inventory file. So the way this is going to work is we're going to go into our cluster inventory.tf, and then I'll go ahead and do resource, and we'll call this local file. And then I want to give it a name, which I'll call it just simply Ansible inventory for now. And then what we want in here is going to be our content. So content equals to just hello world for a moment. Then we want to actually give an output of some kind. So in this case, it's going to be a file name, like where do we actually want to output this file. So the way I'm going to do this is actually going to go ahead and create one more file in here called locals.tf. And what we want to do is we want to define the locals definition, which allows for us to do things like our repo directory, which is going to take in some value here. So you might think it's like .. in this case, but what we can do is we can actually do it a little bit better than that. So we can actually jump into Terraform and Console, and we've got an inconsistent dependency log file. I'll come back to that in a moment. So let's go ahead and comment out the cluster inventory for just a moment, and then we'll go back into the console itself. So what I can use is path.module. So this is built into Terraform. Path.module is just a period. That doesn't tell me a whole lot. So I can also do ABS path of path.module. That is absolute path of path.module. This is actually where it exists on my machine. Yours would reflect that as well. So what I want to say is my repo, my actual repo directory in locals, I want this actually to be this directory right here. The way we do that is by using another built-in function called dir_name. So I can actually take the absolute path and pass that in, and this gives me that value. So that actual output, other built-in features or functions to Terraform right there. So for this, I'm going to go ahead and make some string substitution in here and just do that exactly. So this is now my repo directory that will be the root in here. So back into my cluster inventory here, I can actually now reference that in my file name. So I can now say local.repo_dir. This will now be in the repo directory. I can then go ahead and say something like my Ansible directory. So we'll go ahead and just say Ansible. And then I'll go ahead and say inventory.txt just for the moment. That's not what I'm going to name it in the long run, but I will use it as this. I'll exit out of the Terraform console, and now I'll go ahead and do Terraform and plan. I should see that error once again. Inconsistency dependency lock file. So the reason this happened is because I brought in a new resource, one that I haven't used yet. So this is where you actually do the Terraform init again, but this time we actually use -upgrade. This will allow for that local file management to come in. So basically anytime you add in a new provider that you'd want to use, you need to use that upgrade. If you use a built-in module that Terraform has that's not necessarily available, then you also use that upgrade. So in this case, this local file resource was not available yet, so we had to upgrade it. There we go. So now, with it upgraded, I can now do a plan, and we should be able to see that it's trying to create this file with that content of hello world. That is very, very simple. So now if I run Terraform and apply, hit enter, it's going to go ahead and create that file for me. So go ahead and say yes, and what do you know? Hello world. Great, so definitely on the right track here. But the thing is, this is just, raw string content. Let's change this a little bit. So what I want to do is I want to use some string substitution again. This time I'm just going to go ahead and put in one item in here. I'm not going to go ahead and do the iteration just yet, but I will grab the Linode instance dot Linode servers, and then we'll go ahead and do 0 and then .ip address. Okay. And again, if you need to know what those dot notations are, there's a lot of different places you can look. One of them would be in the actual attributes reference for that resource itself. You got a lot of stuff in here for that. So now if I save that, now it's actually based on one of my other instances. So I can go ahead and say yes. Notice it replaces that file, and there's that IP address now. So naturally, it's about time to combine the idea of managing a local file with this iteration by using Terraform templates. But the other thing is, within this inventory, we can also do something called depends on, and we can say what this inventory file is going to depend on, which is going to be the servers and also the Nomad clients. So both things. So basically, finish provisioning all of that stuff before you start managing this file here. And then, of course, now all we need to do is change the actual content that's going there and actually the extension for the file that is going to be output, so it's actually prepared for Ansible. Now it's time to look at how we can use something called a template file inside of Terraform. So this content right here is going to be replaced with something similar in the sense that we will still be doing string substitution, but now we're going to go ahead and use something called a template file. So we're going to define the actual template file in just a moment. We're going to actually start with the context that we're passing into it. So we're going to go ahead and add in a dictionary here. And so inside of this dictionary is what we want to use for our context. So if you remember back when we did this iteration here, we can actually use this iteration now and say something like servers equals to that iteration. But the nice thing is I can actually separate this out a little bit more so it's easier to read and, well, easier to work with our Terraform modules themselves. And we can get rid of commas and all that as well. Once again, just to make it a little bit more readable in our code. Okay, and so what we've got here is that same iteration with the same output that we saw. Now all it is going to be reused again for both our servers and our clients. There we go. So this is going to be passed into a template file. That template file is going to be inside of path.module. Path.module, if you remember, is that period in here. You could do abs path.module as well if you wanted to, but path.module should work just fine. Inside of infra, we can go ahead and actually bring in a folder called templates, and we'll go ahead and use that folder. So we'll just do /templates here, and then I'll go ahead and create a Terraform template, which is ansible.temp, or we'll call it ansible.inventory.tpl, or there's other extensions for the Terraform template, which I think TPL is another one. But the idea here is we want to actually use those values. So the way it's done is we're going to do other iterations. So the first thing is we're going to declare a couple things related to Ansible itself, servers and clients. So in here what we've got is we want to have basically our IP address, roughly speaking. And we also want to have all of our server IP addresses in here. And then maybe our server private IP and so on. So we keep going through the logic as to what it is our inventory file needs. But before we can do that, we need to actually do the iteration itself. The way this works is by using %, for instance in servers, tilde, curly brackets, and then using that same sort of setup down here, we then say n4. So this variable right here is not corresponding to this. This variable right here comes from this argument right here. So if I said something like nomad servers, the actual template itself would say Nomad servers as well, which might be a little bit better in terms of this template itself. So it's a little bit easier to understand what it is that's going on. So what we can do from here is build out our actual inventory file, which I will. But the thing is, I'll just go ahead and show you by copying and pasting here what's going to happen with this. Okay, so if we see, we've got instance.name. This corresponds to this argument right here. Instance, of course, is that variable, very similar to I in the Terraform template file, but I just named it instance so it's a little bit easier to see. We've got our SSH host for Ansible, which is the public IP. That's the root host that we go into. And of course, we also declare the root user. Then we've got our subnet IP here, and then finally our region. So all of these things are going to be driven through Terraform to build out this Ansible inventory file. And it's going to be the same for both items. This one is just going to be our Nomad clients. So we'll go ahead and change that in our inventory file as well as our context. And there we go. Simple enough, hopefully. The next thing is, of course, this is going to now need to reference that file. So I'm going to go ahead and just copy the relative path, and I will paste it in here. And of course, get rid of all of the duplicates that are essentially in here, which gives us back just the file name itself inside of templates. And then the final output is inventory.ini. We save that. We are also going to add that into our gitignore file. So back into gitignore, we will go ahead and bring in that inventory.ini. This does not need to be public knowledge, neither does inventory.txt, but we're no longer using inventory.txt anymore. So now we'll go ahead and do Terraform and plan. And so if everything was done correctly, we should be able to see that a bunch of things will be changed in here. And so I'll do Terraform and apply. And naturally, I'll go ahead and say yes. And that creates inventory.ini, which has a bunch of arguments in here as to things that we want. Mine is being wrapped, which is why you're seeing it in this format. If I were to zoom out quite a bit, it looks a lot more like a normal Ansible inventory file, even if you aren't aware of those Ansible inventory files themselves. But it gives all of the data necessary for each instance that's in there. There's quite literally 6 of them. But we have one thing that's a problem down here is we've got server, server, server. So looks like we have a naming issue on our cluster inventory file itself. And that, of course, is in this clients. This still says servers. So we need to change this to being clients. So what we've gotten here is a little bit of an issue down here as well. So the subnet IP is going based off of that one single server, which it shouldn't. It should go off of the iteration. And there we go. And this one also should go off of the iteration. Now, the reason I did that is so that you could see the potential issues that you could come up with. It's very obvious if you look at the subnet, they're all the same. You can look at the name, there's repeated ones. So you just need to make sure that you are using the correct values in here. And that's where the console comes in and where you can play around with stuff just like that. So now that we've done that, I'm going to go ahead and apply these changes, and I'll just do -auto approve just to let it automatically happen and just change. With that in mind, I can now look at my inventory file, the Ansible inventory file, and I can see all of the things that are happening in there in terms of the inventory. Great. So we're now in a really good place to start using Ansible. But before I do, I want to show you something that's actually very important, and that is just doing Terraform and destroy, and we can go ahead and say yes. Now, the reason I'm doing this has nothing to do with the fact that we're not going to just reuse this in just a moment, but it has everything to do with the fact if you need to take a break and you want to go ahead and turn everything off, here's how you can do it. Now, before you actually start running your workloads on a Nomad cluster, this is something you're going to want to do on a somewhat regular basis, just so you're not having servers just sitting there running in your actual Linode account. And so it just takes a moment to bring them down, and it only takes a moment to bring them all right back up and bring you right back where you started. So that's what we'll do in the next part.